This is our project titled as GSM Enable Automatic Irrigation. India is the second largest country in the world that depends on agriculture more. Agriculture in our country is dropping due to the reason that it is a profitless business. Though technology provides surplus income or profit, it could not provide guarantee for survival standalone. The reason for diminishing in agricultural activity is improper utilization of the resources. The main resource for the successful agriculture is water. Water is an important criteria and it has to be utilized in optimum level. Overutilization leads to water crisis. In state like Tamil Nadu, the irrigation is dependent on rainfall and wells. It has been reported that the rainfall in Tamil Nadu in 2013 was 17% lesser than the 2000 report. So, the utilization of water from wells has to be optimized. In order to increase the profit in agriculture, it is essential to bring technology into it. By doing so, the manpower of farmer is reduced considerably. This guarantees high revenue in agriculture and also yields good profit to the farmer. In order to provide solution for this irrigation problem, we are doing a project with the help of MSP 430 G2553 processor provided by Texas. Our project objective is to automate the irrigation by monitoring the soil moisture and also water level in the well continuously. The complete setup arrangement is shown clearly. The entire setup is powered by a 230 volt AC supply. The microcontroller is the most important hardware of our project. It performs a logical operation with the input and controls the output. Here we are using MSP 430 G2553 for our application. The various inputs and outputs taken from the microcontroller is shown clearly. The pin description is also provided with the launchpad. The next important thing is the input sensor. A magnetic float switch is immersed within a tank to detect the water level for high level and low level. Now the sensor reads a high value since the water level is high. In case the level is low, then the pump does not irrigate water to the field. The pump is immersed within the water tank. The pump is to irrigate the field when the soil is dry and the level is high. This is a 12 volt DC mini brushless pump that is driven by the microcontroller. The entire field is divided into 4 sections such that each hygrometer is placed in corresponding section. To differentiate the wetness and dryness in the soil, a single hygrometer is placed in a dry soil separately. The remaining 3 hygrometers are placed within the soil to indicate the wetness. The soil hygrometer is to detect the moisture in the soil. It works based on the change in resistance, that is due to the conductivity of the 2 probes when immersed in a wet soil. Thus, the sensor reads 1 for wet soil. The sensor gives a value load to the microcontroller since a single hygrometer is placed in a dry soil, indicating the requirement to irrigate water to the field. Here, a single hygrometer is now placed in a dry soil so that the water is now irrigated to the field. In this situation, a GSM sends message to the farmer indicating the field is irrigated or it is irrigating. When the same sensor is placed in the wet soil, the irrigation stops and the message is sent that there is no need of irrigation. As shown earlier, since the level in the tank is high, the microcontroller monitors only the soil hygrometer, and based upon the moisture content, the pump continues to irrigate water to the field.